too important anyway. So yeah, thanks very much for joining me for this last session. So this is called Measure All the Things, a bit over dramatic, with Influx, Grafana and PowerShell. I'm Mark Wragg. I'm currently working as a contract DevOps engineer for a company called Solid Software Reply. I kind of originally, my start in IT was very much operations focused, so I've sort of been working in IT about 15 years and started always very much at the coalface with regards to kind of in production operations roles. Been on call, done lots of very ops focused jobs, and then kind of a few years ago became kind of aware of DevOps as a concept and a culture and started sort of transition more towards DevOps types roles, which has kind of meant that I've started to work now more closely with developers. Like DevOps engineer, arguably a lot of people say shouldn't really be a job, and yeah, what it seems to mean is I think it's something that already existed, which is that it tends to be sort of build engineering. So you end up kind of tending to work more closely with development teams with regards to sort of working on and managing those automation pipelines around software delivery. But of course, DevOps is ideally about bringing development and operations together. So that's the dream anyway. I presented last year at this conference in London about Pester, which I love, but unfortunately there's no Pester in this. So this talk is really just to introduce you to a couple of tools that I'm hoping most of you haven't already got tons of experience with, because if you have, you might be a bit bored. So I'm not going to ask, because I don't want to know. But yeah, hopefully these are things that you haven't done tons with before. I'm hoping just to really inspire you to make some sort of creative uses with them, because they're really easy to set up, really easy to use. And then PowerShell, because obviously it's a PowerShell conference, I wanted to try and leverage PowerShell as much as possible, both to kind of stand up the stack and then sort of to squirt some data into it. But a couple of notes really. PowerShell, obviously I'm going to use it throughout this to kind of pull data from different sources, but not necessarily the right choice. If you've already got, like some of my examples, I'm going to pull simple things like CPU and disk and network stats into a dashboard. But if you're on a cloud service, or if you're on some service where you've got agents that can pull that data for you, don't reinvent the wheel if you can avoid it. But there's lots of opportunities where standard agents might not be able to pull certain events or metrics for you, and it'd be a good choice for you to then get it out of the platform, particularly now it's cross-platform. And then the tool set described here probably shouldn't be your only approach to monitoring, so bear that in mind. If you've got other monitoring tools, it's intended to kind of replace them. The idea is to sort of supplement them. And then I'm not going to really talk at all about how to run this stuff in production, so I'm not going to give any consideration to backing this stuff up, running it at scale. And I attended this morning a session on securing credentials, and it realised that I didn't give any consideration to security at all. Like, this is all completely unsecure. So bear that in mind. If you choose to run this in production, you need to give some thoughts to those production things. So I want to talk really briefly about why monitoring is important, brackets for DevOps in particular. Obviously, we know monitoring is important in general, it's been around for a long time, but DevOps as a culture is the idea of kind of enabling a company or teams to go faster, to deliver software more quickly, ideally in smaller batches, so you can get your features out to market more quickly. And then once you can do that, it sort of enables you to experiment. So it kind of allows you to kind of quickly deliver features, means you can do more experimentation with what you're delivering and see whether the changes you're making are making things good, better or worse, enabling more sales or, getting more users. And you can't really do those things safely without seeing how those changes are impacting your product. So of course, you need monitoring that kind of shows you, the state of your product, and then when you release changes, how those changes are sort of affecting things with regards to both kind of your business metrics and your application metrics and those sorts of things. Traditional monitoring has tended to focus on availability at its core, so it tends to be sort of ping checks and health checks and those sort of things. You want to make sure the service is up, want to make sure the service is available, users aren't complaining that they can't access the service, which is of course really important, but DevOps kind of requires a focus on metrics and events, like what sort of things are happening around our product that's then sort of causing changes in trends. So and also when you're collecting that kind of data, you're kind of getting availability as a result, because if you're not getting any data back for a certain metric, it's a good sign that your service is probably down. So that's just why this is kind of an important topic. And then this is really just an excuse to tell a story about how stupid I once was. So beware the observer effect. And the observer effect is this theory from science that you can't really monitor something without having an effect on it. And of course, that's really obvious with IT monitoring, because if we're going to run agents or scripts to kind of collect data, we're going to be using up a little bit of CPU or memory or whatever to do that. The story is that one of my first IT roles, I worked for like a internal IT team, and so we were looking after kind of users in the office and network, email, that sort of thing. And we had a problem where this was like 99, 2000. I don't know what the email service was, but we had a problem where email delivery would suddenly stop working, and we didn't find that out until kind of users came to us and said, "Oh, people are saying they're not getting my emails." And it was really obvious when this occurred, because emails would just kind of queue up in a folder on the server. So basically, I was kind of familiar with Visual Basic at the time, so I wrote a little Visual Basic tool that basically checked this folder to see how many files were in this folder, and then had a little traffic light graphic that would change between green, yellow, and red depending on how big the folder was. And we stuck that on an old CRT monitor on top of a cupboard, and then we had a little display in our office that showed us when we might be having email delivery problems. So got loads of praise from management. Oh, really proactive, great, love it. But then a couple of days later, they kind of noticed that the network in the office, network traffic in the office, had kind of shot right up. And it took a few days to kind of trace it back to where all this extra network traffic on the network was coming from. And what I'd done in my little Visual Basic tool was I'd sort of said, I want my traffic light to change as soon as possible if the queue gets big. So I just had it set to just check this folder as fast as it could, which was like 10,000 times a second. So stupid example, be careful with how you leverage your monitoring. Monitoring is really important, but just be mindful of what you're doing and what impact that might have. So this is DevOps isn't about tools, but this talk is. So DevOps. So the tools here are these three. I just want to quickly talk about what they are and why I chose them. So Influx is a time series database tool, which basically means that it's a database that's been built from the ground up with the intention of storing time-stamped data. So not just storing it, but also enabling you to sort of very quickly kind of query it and run queries against it. So it isn't something that's been kind of converted into that. It's been sort of, the intention of it was always to be a time series database. It's really great because aside from creating a database in the first place, you then don't have to kind of go in and create any tables or schema as you start to record metrics. So once you've got your database, you fire your metrics into it. If it doesn't yet exist, it just automatically creates some container with which to track that data. So it becomes like this really flexible tool. You don't have to give any pre-thought or pre-planning to kind of what sort of data you're going to store in it. You just start sending stuff to it, and if it doesn't already have some container to track that, it creates one. And if it does, then it sort of supplements in that data. None of these people are paying me to talk about their tools, so I listed some alternatives. Grafana is then the front end. So Grafana is a dashboarding tool, and it's really, really popular, and it's probably the thing that most people might have had some exposure to previously, because it allows you to kind of, it's got this lovely GUI interface that allows you to kind of throw together really quickly and easily these dashboards and graphs to pull data, not just from so I'm going to use Influx as kind of my primary backend source, but you can point to multiple backends, and you can have single dashboards that's kind of correlating data from different backends. So if you've already got data in Azure Monitor or CloudWatch or other services that it can query, that it's a great way to kind of bring data from different sources together and see them side by side. And then, of course, PowerShell. So, as I said earlier, if you've got monitoring agents, Influx itself has a little agent called Telegraph that you can run on Windows, and you can, or I think any operating system, and basically configure it to collect kind of OS-based metrics. But PowerShell is a nice choice if you don't have something like that, or if you want to use PowerShell to grab something a bit more unique from your system, then PowerShell is a really nice tool, because Influx basically creates a RESTful API that you send data to, and I'm going to show you that in a sec. Deploying these tools is really easy, except for they don't have kind of installers in a traditional sense. So you download them. Both Influx and Grafana are just kind of mostly just an individual executable. So on Windows, you download it, you run it, and then you're it starts a service and it's listening on a certain port. So if you want to run these on Windows as a service, there's a little tool that's been around for donkey's years called an SSM, the non-sucking service manager, which is a great little tool for running any kind of executable as a service. So what I've done is I've written an installation script, which I'll show you in a sec, that basically just it downloads these files from their source locations. It installs an SSM using Chocolatey. It installs Chocolatey and installs SSM using Chocolatey, and then it expands the archives installs these things as services, and it makes a couple of little configuration changes to their configuration files. But I strongly advise that you also look at those configuration files and become familiar with them, because obviously you can configure both of these with different settings through these config files that live alongside them. So the script that I've written basically is very quick and dirty and just will install them on whatever machine you run it on. If you're familiar with Terraform and you want to kind of stand up a virtual machine in either AWS or Azure, do the same thing. I've written a Terraform script that you can get from my GitHub repository there. And that basically it does kind of the same thing as my quick install script, but it stands up a virtual machine, network rules, allows kind of the port open, and then creates all the little bits of infrastructure around plus a virtual machine, and then bootstraps that virtual machine in the same way as this install script, in that it goes and kind of downloads the installers, expands them, configures them depending on what variables you put in the Terraform script. So yeah, 2 ways to kind of stand this stuff up. My to-do list. Okay, so this is my install script. I've already run it because it's quite boring to watch it run. Basically, all it does, it tests if you're an administrator. Say installs Chocolatey, installs the little NSSM tool, and then we download Grafana from of a specific release, which is sort of controlled through these parameters at the top. Expand it, stick it on the C drive, and then we make a configuration change in the install instructions for Grafana. It bases on Windows. Port 3000 has some restrictions, so it doesn't recommend you run it on port 3000, so we just change it to some other port of our choice, and we go with sort of 8080 in this instance, but obviously you can customize that. Creates a local firewall rule just in case we need one, and then installs it as a service and starts up that service. Does the same for Influx basically, and the only thing we're doing after we've created Influx, if you were doing this manually, you'd also need to create a database. So Influx comes with a little command line CLI tool that you can basically run, and you can use interactively to sort of interrogate the databases and create databases and kind of run queries and things. So we basically use that tool to just create a database for us to start with. So we're just going to create a single database, but you can have multiple databases if you want to. And then I'm also enabling a UDP listener, which I'll cover in a bit more detail, but I just basically dump a little bit extra bit of settings into the configuration file to turn on Influx's UDP listener, and I'll explain in a bit why I've done that. So I've run that already earlier today, so that we've kind of got a nice kind of clean new install of Grafana and Influx. So once you've kind of got Grafana installed, you basically go to localhost and the port that you've selected for it, and you'll be presented with this login screen. The default credentials are just admin and admin, so you log in with those. I want you to change the password, but again, giving no mind to security, I'm just going to skip it. And then you kind of come to this home dashboard. So it's got a nice little wizzy that takes you through kind of steps that you might need to do. Firstly, you need to add a data source. So Grafana is just a front end, so we need to tell it kind of where we're going to use for back end. So it supports Influx by default, so we just tell it that Influx is our data source. Because we're running it on the same machine as Grafana, we can just tell it just needs to look at localhost, and that's the default port for Influx. And then we just need to tell it what database we want this to use, and it pre-populates these. We've got any credentials, hit save and test, and we should see data sources working down the bottom to confirm it's kind of connected to it. So that's now Grafana connected to Influx. And then it wants you to kind of go in, start creating a dashboard. So you go in your dashboard and you get this empty dashboard of the panel that you can create. Now we haven't got any data yet into our Influx database. So I've got a little script here called write into Influx. So what this does is basically uses invoke REST method to post to the Influx API using what Influx call their line protocol. So basically you kind of post data in this format, which is that you kind of have the name of a measure or metric, and then you can optionally have a set of kind of tags which you can use to kind of filter the data. So these are my tags, and then you've got you can have one or more basically the metrics that you're actually kind of recording against that specific measure. So you can have sort of one or more fields. So that's what kind of this line protocol is doing. And then I'm just going to send this in with invoke REST method. So if I run this now, I've got verbose on, so we'll see the posts occurring. If I now go back to Grafana, so I can now go add a query. So this is like the default kind of visualization is this standard kind of graph visualization. And because I'm now sending in, so I didn't have, like this was a blank database, so I didn't have that measure before called CPU load. Oh, I did actually because I ran this morning, but but you can see when I click select measurement here, I've already selected sort of Influx is my default source, so I have to select a source here, but my measure now is here in this list, so CPU load, so I can choose it. And you can see I did a little test this morning, but you can see I wrote some data this morning. We go down to the last 15 minutes and configure this to auto refresh every 5 seconds. You can see we're getting data points come in that represent my CPU. Obviously that's not hugely readable, so what we can do is kind of say we want there to be lines between these points. We set fill to linear, and now we've got lines between the points. And then you can further kind of customize this. Like because I know this is CPU percentage, like at the moment it kind of creates like an automatic scale, but that's not necessarily very informative. I know that it's going to be between 0 and 100, so I can set it to 0 and 100. I know this is a percentage that I'm getting, so I can set that to make that a little bit more clear. And then I can set, I can give the power title. So we're sort of proving now that everything's working. We've got Influx working, PowerShell's writing data into Influx, and we've got Grafana that's now visualizing that data from Influx as a source, and it's refreshing every 5 seconds, and there's the data coming in. So, having done that, let's now flip over here. So that's sort of, I don't know about you, but I didn't find that hugely intuitive to remember. So what I did when I sort of first started working with this a couple of years ago was I created a PowerShell module for writing to Influx. So on, should not go back to my slides. So yeah, on the PowerShell gallery, I've created a module called Influx, which you can install. And basically what it does is it allows you to kind of write to Influx, basically using hash tables. So it just kind of, it takes a bit of the weight out of kind of generating that line protocol for you. What you have is this write Influx commandlet, and then you've got your measure, which you give a name to the sort of measure that you're recording. And then again, tags is optional, but if you're sending some tags in, you just need a hash table of your tags. And if you're sending some metrics in, one or more metrics, just send a hash table of metrics. So basically, with this example, I'm now going to write both CPU and memory from the performance counters, but now using my write Influx commandlet. So I think it makes the input a little bit cleaner. It also handles for you because you might have, in the stuff that you're sending in, you might have characters need to be escaped, and the commandlet will handle that for you, so you don't have to worry about sort of escaping reserved characters if they exist in your, the names of the things that you're putting in and what have you. So yeah, it's designed to sort of ease that. So let's run that. Again, I've got verbose on just so that I can see that it is actually writing into, and then I've also nicely the verbose output for this is showing me kind of exactly, it's sort of showing me the line protocol so I can see exactly what's being transmitted, which is really nice. So if we go back to Grafana now, we'll dump this, create a new one. So create a new panel. I'm now writing to a measure called server instead, because I'm not just doing CPU, so I've decided to call the measure server. And because I didn't call my field value, which is sort of the default here, I've now got two fields that I'm writing into this one measure called server for CPU and memory. Now I can set them individually, or I can just stick a star in here and it picks both. So now you can see I've got my data points coming in for CPU and memory. Now obviously CPU and memory operate on different scales, so it doesn't necessarily make sense to have a single axis for those two. If I wanted to, I don't have to represent them on the same graph, but in this instance I've decided I want to. But what you can do is click here and you can move one of these over to the right hand axis. Now it's sort of over on that side. And then again I want to join these together. So now I can go in to kind of customize this. My left hand axis is now still my CPU, so that's a percentage. And it's between 0 and 100. This one is now it's data, I think it's megabytes. Maybe? That seems about right, doesn't it? And again, obviously it's going to run between 0 and I've got 8 gig of RAM on this, I think, so I can sort of set that scale so that I get a more realistic looking graph. But now I've got two metrics on the same graph. Call this server. and again, I've got data really quick and easy just to get data flying into Grafana and displayed and visualized. I can also, I didn't cover it, but where I added those tags, the flexibility is I can now kind of, within this where clause, this is kind of building a query for you, but because I've added those tags, I can filter this data. So say I was writing from multiple machines to the same measure, which I might do if I've got a fleet of servers and I want to kind of track the CPU memory of all of them, send them all into one measure called server, but I kind of go, well, I only want to see the servers that are in the UK South region, then I can kind of create graphs and filter the data that way. And similarly, I can use this group by option to kind of group by certain things. So say once I've got kind of multiple hosts all writing to the same chart, so it's going to get confusing as to which line represents which host CPU. So if I group by one of my tags, then you can see that I've only got one host here, but you can see that as a result I'm going to get, it's going to tell me which host is which line. So that's sort of an option you have when you've got kind of multiple stuff coming in. Okay, so that's writing my CPU and memory. Now I'm sending that through write-influx. So what that's doing is writing via TCP. It's just using, say it's using invoke REST method, which is obviously making a TCP connection to Influx. So if Influx was down, then I'm going to have to wait for a timeout to occur. I'm going to get nasty error messages come back in my PowerShell script saying that it couldn't connect to Influx. And that might not be desirable. Particularly if you kind of, which I'm going to show a bit later, but if you're embedding this kind of tracking into some existing script, then you might not want your monitoring being down to stop your script from running, right? It sort of makes sense. It's sort of a secondary concern. So that's where the UDP listener is this really nice alternative option. So you can write via UDP, and I expect you guys all know, but TCP being stateful, UDP is just stateless. You transmit your data, and it's just going to move straight on. It doesn't care whether, it doesn't wait to see if it's been received or not. It just moves straight on to whatever it's going to do next. So so Influx, I configured when I installed it with this UDP listener, and then my module has got a command that's called write-influx UDP, which just allows you to transmit data through UDP. So just to demonstrate that, here we've got write-influx UDP. So very similar to what we were doing before, but note here that we now point to an IP address and a different port number, and we can't point to a specific database when you're writing via UDP. What you have in the Influx config is the database is configured when you configure that UDP listener. So if you see when I installed it, I actually kind of point to a database as part of the config of the UDP listener. So it points to whatever database the UDP listener is configured for. If you need to write to different databases, you just configure multiple UDP listeners on different ports, and you send to different ports to different databases. But in this instance, I'm going to write to the same database that I use for my TCP requests. I just have to point to a different port and an IP address. Again, I'm doing the same thing. I'm writing my memory and my processor. So if I run this script, again, the verbose output is going to show slightly different output, but again, you can see what's being sent through the verbose output. If I go back to my Grafana, it will have stopped briefly, and then you can see it's joined the points together, but you can see now we're getting data again. Now, if I were to stop Influx, we're going to see this disappear in a sec, where Grafana realizes that suddenly it's not got a back end to talk to anymore. But as far as my script's concerned, doesn't care. It's just carrying on, still transmitting stuff, or attempting to transmit stuff regardless. So obviously, much less of an impact. Coming back to that kind of thought about the observer effect, I've minimized the impact on my host and my script by using UDP instead of TCP. So it might be a good option if you're getting data into your monitoring system is secondary to making sure that your script or your server isn't kind of impacted by that act. I must remember to start this back up. Okay. Just see this come back to life. Well, let's assume it will. So that's basically everything you need to know, really, in order to start building these dashboards. You've got Grafana as a front end. You've now got a couple of tools in your arsenal for how you can kind of send data into a store that allows you to then start visualizing it with Grafana. The rest of this talk really is just to give some thought to, well, what can we now monitor? What can we use PowerShell to grab? And as I say, rightly or wrongly, you might have other agents that can get you kind of operating system and infrastructure metrics. You might not. So I've got some examples around that. And then, give some consideration to where you might embed monitoring into your application logic. So obviously, there might be points of your application where you want to kind of know how long is a certain task taking to run, how many errors are occurring. Sort of having a history of that allows you to kind of create trends around where errors are occurring, and then you can kind of, when that data changes, that can be really informative. And then business logic, which is things around like kind of, how many sales are you making, what's the value of the sales, how many new users are registering. If you're finding ways to kind of pull that kind of metrics in, and that's obviously really informative. And then finally, your deployment pipeline. So stuff around kind of, what deployments are you doing? Are they being successful? How long are they taking? When are they occurring? And the real beauty of Grafana is sort of take information from all of these different sources, bring them together and put them side by side, and you can start to sort of draw conclusions from the fact that you've got this data together. So some examples for that. So CPU, memory, disk, network, obviously dead easy to grab with PowerShell. So I've got an example here. Let me go back to the right influx metric on this example, but basically, again, I've got my influx connection details. I'm splatting into my commandlet, so I'm declaring those at the top. I've got my tags, which can be as many as you like, whatever you need to kind of categorize your data, as many tags as you like. Now I'm going to grab my memory and my CPU, but also network in, network out, and then I'm going to loop through. I'm going to use WMI, probably wrongly, to grab my disks, and I'm going to loop through however many disks I've got. I'm then going to send for each disk. I'm going to send in, what's the name of it, how much free space has it got. I'm going to calculate what's the percentage of free space, what's the percentage of use space, and I'm sending that in as a measure called disk. I'm sending the network in as a measure called network, and I'm going to continue to send in my CPU and memory as a measure called server. If I run this, again, I've got verbose switched on just so that I can see the output. Loads of stuff coming up now. I had to add 2 hard drives, by the way. I hope you appreciate it. I had to add 2 hard drives to make this more interesting. So I should see this graph continue to kind of gain data. Now I can add a panel for my network. So again, network. I've got my 2 fields. Again, this has all been created on the fly. I haven't had to go in and create a network measure in the database. It just didn't exist before. You can see this list is building up. I've now got network. I've now got disk. Again, I'm going to just hit staff because I want both the fields. Don't need to put these on different axes because they're effectively the same measure, but I can, again, I can set this to, I want to say bytes. Can't remember. It is bytes. And then again, I can sort of customize this. Some lines. Maybe fiddle around with the colors a little bit to make it more pretty. And this is my network. Again, really easy to just, you've got multiple panels. It's this lovely graphical interface. You can just kind of size things as you want. And then I'm going to add my disk. So for this one, just to mix things up a little bit, I'm going to use this bar gauge visualization because it's quite Star Trek-y. Going to set this to vertical. And for my data, I want my disk. Now I've got multiple disks. I want to look at, say, used percent. Now by default, because this aggregator is set to mean, so it's kind of doing an average, and that's now showing me the average space across all my disks, which is perhaps not a very informative measure. So here's where I need to use my group by field now, because I want to group by device ID so that I can see an individual bar for each one of my hard drives. And then, because this name's a bit unpretty, you can use this to basically reformat that. So now that's changed my disk labels to be a bit prettier. And again, this is a percentage. So let's just set that to percentage. And I can have in here, I can have an orange section. So say when it's over like 60, I want to kind of consider it as in a warning state, as it were. Again, just really simple to just kind of drag these around and make this one basically run up the side of both of these. This is something new to Grafana. It used to be that you had to kind of create lots of rows and then have your kind of panels in different rows, but now you can just have something that expands vertically across multiple rows. As a result, create really pretty interfaces. Put that over there. These aren't the best things. There we go. We've got sort of network, CPU memory, disk, all-on-one nice little display. Okay. So you can also do alerting through Grafana. So you need to kind of set the configuration file. You might need to like configure an email server, SMTP service, if you want to kind of send out email notifications. And actually, you can't do, although this looks pretty, I can't do an alert based on this visualization. It needs to be this kind of visualization type. So if I wanted to have my disk space alerting, then I'd need to sort of create a graph for my disks, which I'll do just quickly in the same way. So use space, complete lines. So there we go. I've got my kind of my disks on a graph now. And basically to set up alerts, you've got this little alerting panel down here. So you just hit create alert, and then you can basically say, I want to know when is above or is below, and you've got this little kind of thing you can drag around here. So kind of go right, when my disk space is, my used space is above a certain threshold. I basically want, if it's above that over a 1 minute period on average, then I wanted to kind of trigger some notification to me. So yeah, you can use Grafana for alerting, which is really nice. And what you'll see, as I've set that so that it's kind of below this threshold, in a minute, what we'll see is that the panel will start glowing red in a sort of an angry way, and this heart will change. And also you get an annotation, so you'll get a line show on the graph that basically says, here's when we went into kind of an alert state, or a red line. And then you'll get, if we come out of that alert state, you'll get a green line appear on the graph showing we came out of that alert state. So really nice, again, sort of visual way to kind of see as and when historically you've moved in and out of these kind of alerting states, and it does that for you automatically. Put things up. Okay, so we'll leave that to continue running. So that's alerting. So yeah, annotations. So you get these automatic annotations through the alerting system. You can also add them manually, although when I recently tried this, it didn't work. But if you hold Control or on a Mac command and kind of click and drag, you can kind of manually add an annotation. See if this stays. No. For some reason disappears, but it shouldn't do. It should stay there. Grafana basically has its own data store where it should be storing these annotations. But that's one way in which you can add your own kind of manual points to the graph, so it can be interesting. And then you can also add them basically automatically via query. So giving some thought again to, with DevOps, you want to kind of track events. Events are really important to us. Giving some thought to what kind of events are interesting in the Windows world. One of the ones that obviously might be interesting is when the machine last rebooted. So I've written a little script here called write Influx startup. And the idea of this would be kind of, you could configure this to run as a startup task in Task Scheduler. And what this is going to do is basically just run on the boot of the machine. It's going to grab the last boot time using sim to see when the machine booted. And then what it does with that date and time is it checks the event log for any events after that time, so basically after the most recent boot, to see whether 6008 has occurred. 6008 is an indicator that you've had an unexpected restart. So if it finds that event, it goes, well, the machine rebooted and there was something, it wasn't a planned reboot. So we write a metric into Influx called startup, and we write it either saying unexpected restart or restart as its value, so it's getting a string value as the value of the metric. And also, we're using the timestamp parameter on this occasion. So we're writing this event at the actual time that the boot occurred. All the other times I've written to Influx, I haven't provided the timestamp. So the timestamp that's got assigned is basically whatever I wrote to Influx. But on this occasion, I'm saying I want it to, if I run this script now, and my machine rebooted this morning, which it did, that's when I want the event to be represented in Influx. So let's run this now. Worry about honestly. There we go. So I could just now create a graph manually, and on my graph kind of visualize my startups, but on a graph on its own, it's not necessarily very interesting. But as I say, I can use this automatic annotations system to basically have annotations added to my graphs. So to do this, you go into the settings of the dashboard, go to annotations, add an annotation query. We'll call this one startups. And basically, you can, by default, you can have toggles at the top of the dashboard to allow you to kind of turn these on and off for when you want to. So I should make a toggle appear, but again, it's been a bit ropey. Saying we're coming from Influx, and unfortunately for this, you haven't got you have to actually kind of write a query using sort of the Influx query language. But basically, what I'm saying here is I want the restart metric, and I also want the host field. No, I want the restart and host fields from the startup metric, and then where $time filter is an automatic variable. And then I'm going to add in here host. Basically, just when it adds the annotation, it's going to add the value of host to that annotation automatically. So I hit add on this, go back to my dashboard. If I change this to be last 12 hours, we'll see now we've gained an annotation that has shown when that machine rebooted, and also because I added that host field, which machine rebooted, and because the value of the metric that I'm writing is either restart or unexpected restart, I can see here that it was a planned restart, it wasn't an unexpected restart. So again, perhaps useful, you've got other data, it's the idea that you kind of, on whatever graphs you think this could be interesting, you kind of overlay this on the other data that you have, and it might give you insight into, oh, that's funny, this machine didn't used to reboot that frequently, or oh, immediately after this kind of restart, suddenly I'm having problems, or my number of errors has shot right up. It's allowing you to kind of draw data from different sources together and see them in one place to make it informative. So, last little piece really, I've kind of rattled through a bit too quickly. This gives some thoughts, sort of measuring application performance. So, again, sort of pulling together some of the things that I've covered already. What I've done is I've created a sort of a fictitious app called My App, which is really stupid. For some reason, it gathers my processes, my servers, and the files in ctemp. Don't know why I do that and then not use them. But really, this is just to give this script something to execute and to create some execution. And then I'm sort of imagining that this is an application that I kind of want to run on a regular basis. So what I've done is I've created, I could within this script embed calls out to Influx. Again, using that write UDP, I might kind of add lines in here saying, oh, I want to write to Influx as this script does different pieces to tell Influx and to track when it does different pieces, or how different pieces take, how long they've taken, or when errors have occurred. But what I've done in this occasion is I've written a little wrapper script that wraps around the top of it. So we're imagining this as a scenario where I need this script to run every 5 seconds for some reason. Here's where I'm running my script. I'm dot sourcing it here, and I'm using measure command to basically find out how long it's taken to execute. And then I'm try catching and spit out any errors that occur. And basically I'm using the built-in $error variable, which I'm clearing out on every execution to count how many errors have occurred in that application. And also I'm using that execution time. And then basically I'm just, at the end, every time this executes in the finally block, I'm using write influx UDP to write those two values. So if I run this, flip back, I'm going to create a new dashboard. Nice thing about Grafana as well is it sort of version controls your dashboard. So if you go in and make changes, you're building up this sort of version control, and if somebody goes in and breaks your dashboard and you want to kind of revert back to a previous copy, you can do really nice and easily. But I'm going to create a new one for this. So I'm going to add now I've got my app metric. Again, didn't exist before, but I started writing to it. Suddenly I've got my app as a metric. And I say I've got errors and executions. So again, I'm just going to I want both of those. I don't want them to be on the same axis because they sort of have different meanings. So this one's going to be red because it's sorry. This one's going to be red because it's my errors. So I'm going to have some lines in between them. My execution is on the right, so my execution is time. So again, we can set that to show that it is a time field. I think it's seconds. I'm going to set this to auto refresh. So we should default to 6 hours. That's not helpful. So we can see my script's running every 5 seconds, and at the moment the execution time very quick. It's running sort of in It's taken around 80 milliseconds, and I've got 0 errors, and that's not very good. My error should start at 0, and then it'll be negative. There we go. Now it looks like I've got 0 errors, and not more than you'd expect. Like a 0 there as well. So I've got no errors coming from it, and it's running quite quickly. Now imagine that I've got a Azure pipeline or some other CI/CD delivery pipeline. Was going to spin one up, but decided not to. So just use your imagination and pretend I've got a pipeline that does deployments. I've got this script called deploy, which I'll show you. Basically what deploy does is I've got sort of 3 versions of my app. So basically, currently if we're on my app, it switches it to my app 2. And then if we're on my app 2, it switches it to my app 3. And if we're on my app 3, it just goes back to the original my app. But each time that it makes that change, it also writes to Influx a deployment measure to basically say, oh, I've done a deployment. So I'm gonna run deploy. And what we should see is it doing a deployment of my app 2. And then on this dashboard, again, I'm going to add an automatic annotation called deployments. And I'm going to grab that. Oh, just set that to Influx. Pop my query in there. I don't want to do any of that. Now I've got my deployments annotation. If I go back to my dashboard, you can see a line on my graph for when a deployment occurred. So now I can see, although this is a contrived example, I can see that my app was running really quickly, and I'm not getting any more errors, but since my deployment of version 1.02, execution time has shot right up. So I don't know what the developers have done, but screwed up my app for some reason. So I'm going to run another deployment, see if we can fix it with version 3. And version 3 is now run. So again, I've got this another annotation on my graph that shows another deployment has occurred. So imagine this is in my pipeline as a step. My Azure pipeline's got a step that basically every time I run a deployment, just go and tell Influx, just dump a little metric into Influx so I can see when deployments occur and I can visualize them on my dashboard. Now my execution time's gone right back down to nothing, but suddenly I've got an error that I didn't have before. So I've got 1 error coming out of my app, which is not great. And again, like, you know, if I was tracking this over time, or imagine anywhere in your script where you're using sort of try catch in your catch block, you perhaps write out to Influx to say an error has occurred and this is the app it came from, or this is the source it came from. You'd suddenly be building up this really interesting data that would tell you on a dashboard how many errors are occurring in your app. So we're going to flip this one more time back to the original version. So this was 103, got deployed. We've rolled back to 101, and everybody's happy again, and people have stopped shouting at us. So yeah, I mean, a contrived example, but just again to just demonstrate that this is a really nice, powerful tool, really quick and easy to use. Bring data from different sources together, where that will give you insight that will help you to understand what's occurring. Because the idea of this really is kind of, you know, something's gone wrong in my environment. How much digging around do I have to do to try and work out what's gone wrong? And a lot of the time, when something's gone wrong, you have to go, well, what changed? And people go, oh, I haven't done anything. There haven't been any changes. But there always has. 99% of the time, someone's changed something, and that's why things have gone wrong. I don't think hardware fails as often as you think these days. So yeah, having this kind of data, or having been tracking this kind of data in advance, giving you that insight, giving you the ability to get that insight quickly and get back to, you know, what's going on. Again, another example might be you've got some sort of change management system. If you're working in an ITIL type world, again, if you can tie into that change management system to tell Influx whenever a change has been scheduled for, and you could display it on the graph, that might give you an insight as to what changes were occurring to related infrastructure around the time things started to go wrong. So yeah, that's I think the conclusion of this demonstration. So yeah, really just to summarize, these tools are completely free. I think there are enterprise versions of both, so if you want more support, or if you want to use them more in earnest, or you know, cloud hosting and that sort of thing, I think you can get enterprise versions of them, but they're open source and free tools, so there's no reason why you should just go grab them and start using them. The key here really is about, you know, making the impact of work visible. It's about kind of, again, this sort of the idea of the culture of DevOps is we sort of be transparent and be open and just share So it's about kind of getting stuff visualized and visual and out there, and people can see where things are performing well and not performing well, and what occurred around those times. And then this kind of tool allows you to sort of provide monitoring and dashboard as a service to the business. So Grafana says it's not difficult to use. So you could kind of control how and where you're collecting the data. And there's no reason why you couldn't go give to your project managers or other stakeholders in the business that want to provide reporting and metrics or have some visualization of something. No reason why you couldn't create them as a user on Grafana and allow them just, hey, here's this tool, you can create your own dashboards, you can create your own data, tell us what you want us to collect, and we can create dashboards to allow you to do that. And yeah, when I worked in ops, it was something that used to bug us all the time. People would come to us and they want to kind of hijack a monitoring system, or they want us to spend lots of time generating reports for them. So this kind of self-service system, I think, can be a great way to kind of allow your stakeholders to get the information they need without having to take up your time. Obviously, build what works and is useful to you. Like everyone's environments, everyone's responsibilities are different, so you need to kind of just give thought to what data you can collect and what you can visualize and how you can visualize it to make it useful to you. Take a microservices approach to what and how you monitor, by which I mean, like most applications these days are these like incredibly complicated beasts where no one person has this sort of single view of how everything works. We all just know it works through magic or unicorns, but give thought to kind of what's important to your team or your part of the product or each individual component. Build dashboards around each individual component. Where this came from for me was I went to a WinOps meetup a couple of years ago that was at Shazam's office, and they basically had an open plan office with pillars through the middle of it, and every pillar was basically covered with screens, and basically those screens had lots of Grafana dashboards on them that showed different metrics that were important to the team that sat kind of closest to that pillar, was what I kind of guessed, because they weren't there. But yeah, you could see that each kind of pod of desks was different kind of product line or microservice or something to do with the different products that they provided. So yeah, it was a great way to give that team insight and visibility. And while of course dashboards are kind of, a lot of the time they're used to sort of impress customers and stakeholders, and they come through and they go, oh, that looks impressive, but nobody actually gets any useful data from them. The idea of this is, use them. You shouldn't have to stare at these all the time. Using the alerting service allows you to kind of be drawn to them when you need to, or be drawn to them when you have events that occur. But if you've given thought to what you're kind of collecting and how you're visualizing it, then it becomes this quick and easy tool to allow you to kind of troubleshoot. And then consider what's useful when combined. So consider what side by side works well together. So Influx you can grab from Influx's website, Grafana you can grab from Grafana's website, and all the code examples that I've shown today are on my GitHub under my presentations repo. So have a look there if you want to have a closer look at any of the code I've shown today. Does anyone have any questions? Oh no, I don't want questions. No, go on. No, go on. Yep. Yep. Yeah, I guess perhaps you go down the route of sort of log analytics and have your apps rotting out to logs, and then use some sort of log analytics type tool like Elasticsearch or something to kind of query logs and build your data from that logs. I know that again you don't obviously have to use PowerShell, as I've said. Like if you've got an app that's written in .NET or whatever language you like, there's libraries already out there to allow you to kind of send metrics to a service. Using obviously the native code base of that application. So if my developers were like, oh, I'd like to send some metrics into Grafana, then I'd say, well, if your app's .NET, use the .NET library to do that. Etsy created this thing called StatsD, which basically is a similar kind of thing. It's another way with which to sort of communicate metrics using this sort of simplified language that allows you to kind of say, here's a metric, and then I want to kind of set to this value, or I want to increment it. Every time a new user registration occurs, I want to kind of increment this counter. So that's a nice tool, and again, like all the languages have basically a way to send sort of statsd, and Influx can be configured with a statsd listener, so that's another kind of option. But yeah, if you say you had some sort of legacy application that you couldn't add code to, but was creating logs that were useful, then I guess I'd be looking to kind of write something to analyze the logs, and then point Grafana to that log source and start to visualize that data that way. Hello. Yeah, I mean, definitely. Although I'm a complete fraud because I used this a couple of years ago and then haven't put it together in some of my more recent jobs, and I keep meaning to. But yeah, absolutely. I mean, like, again, you need to be mindful of how you look after your Influx database and that you're giving thought to once that data starts to become really important, you're backing it up and you're managing it in a good way. But one of the really powerful things about Grafana is it allows you to visualize data over like crazy lengths of time. Um, so yeah, definitely. So the longer you're collecting data, the more you're going to be able to sort of see trends. Um, but yeah, I mean, there's some really nice. Again, like obviously, like this is just looking at the last hour, but you can kind of go. I don't know how much data I have in here, but this is like over 5 years, and it's so quick to be able to kind of query the source and sort of render the graphs in a way that allows you to see the data over, whatever um, time period you find most useful. There we go, that's a bit better. Certainly, like, I don't know if you can do two different times at the same time. Like, as you change this time range, every graph is obviously being changed. So it allows you to sort of look at a time range for different metrics over the same amount of time. But I don't know. I don't know if it has a good way of kind of going, oh, I want to compare this year to last year, except to just basically display the 2 years. Yeah, 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 certainly, yeah. Um, I don't know that. I really like that you can. Yeah, you can create templated dashboards as well, where you sort of have fields that then you can tweak. And again, I really like that you can sort of just drill in as you sort of see trends and you see sort of or outliers. You can just really quickly kind of drill into the fine detail. Is there another question in here? Yeah. Yeah, I think Influx does. So yeah, Influx does. I don't know what it does by default, but definitely have looked at that in the past. And you can configure rules on Influx that basically say, oh, after a certain amount of time, just dump it off, or after a amount of time, start to aggregate it down to time frames that are sort of So I don't need like every minute of data, but I like seeing it as a monthly data is still interesting to me. So yeah, definitely you can do that with Influx. We're hoard. Yeah, we're hoarders. Mm. Disk is cheap. That's always the answer, isn't it? Yeah, absolutely. Anyone else? Again, not that I've seen, but a bit of a fraud. Haven't used it in as much earnest as I would like to. Um, yeah. It's very clever. Particularly, I think if your source is this time series database, then it's very well designed with regards to sort of if it knows it's querying over a certain amount of time. Grafana knows that it's not going to be able to render a pixel for every minute if you're looking at the data over a year. So I think it quite cleverly queries in the right and aggregates the data in the right way so that it's rendering only what's useful and only pulling what's useful is my understanding. Madness. Multi-cloud madness. Cool. Any other questions? No? Okay, thank you very much for your time.